So here's a diagram I set up that uses the tmats block and a function block. These blocks you can get to from your library browser. Function is just a basic function block from MATLAB. You can take that and drag it in. The tmats block, you need to have tmats loaded, and it's just tmats solver, and then it's this SS on our solver with Jacobian calc. So essentially we're using the SS solver because it's more simple. It works when you don't have really any dynamic effects going on, and it uses the Simulink time step as its iteration. So if you have dynamic effects, it's gonna those are going to be happening while the thing is trying to step to a solution. So the first thing we do is we set up our function. So here we have u of 1 minus 5, and then we set up our solver. The first thing to set up is the Jacobian perturbation size. This is in fraction, so there's only one input, so we only have one value. So we have 0.05, which is 5%. We then have our initial conditions. We don't want to make it too easy, so we set it to 1, which will make it move a little bit. We also have a delta x limiter, and that's set to 20%. So at each Newton Raphson step, it can only move by 20%. You then also have the Newton Raphson attempts for Jacobian recalculation. So at each iteration step of the Newton Raphson, it'll use the Jacobian that has already been calculated, unless it proceeds 20 times and can't get a convergence, and then it'll recalculate the Jacobian. This final one is a condition limit. Once the values going into it become less than that, it will consider the system converged, and it'll stop trying to iteratively solve. So out here you have the converged variable. This pretty much just says whether you've met that convergence, and this is the variable going in. So we ran that, and you'll notice by inspection this function u of 1 minus 5, you can see what would solve this, and it would be 5. 5 minus 5 equals 0. So here you can see the answer going into it is 5, and the thing coming out of it is 8 times 10 to the negative 16th, which is well below our convergence factor. You can see our Jacobian matrix here is 1. That lines up with the slope of this function. The derivative of u1 minus 5 is 1. So if we stick in here something that can't be solved, we'll just demonstrate that real quick. So u1 squared plus 5, obviously something squared cannot be a negative number unless you have imaginary numbers, which this type of solver won't do that. So we can try to run that. So as you can see here, it did not converge because this value is 0. This value is stuck at 5, and this is some very small number. If you look at how it attempted to solve it, you can see that it started at 1, and then it moved down and tried to go and lower, but it really couldn't. It bounces around a little bit, but it can't solve for the equation. So here's the error. So it started at 6, and it moves down to 5, and then it can't go any lower. You have to take situations like this in mind when you have equations that you want to solve, but it has these types of things happening in them, because the solver won't be able to do it. So now let's look at something a little bit more interesting. Go back to our minus. So we'll do u1 minus 3. So now by inspection you can see that u1 minus 5 times u1 minus 3. There's two possible answers. You could do 5 or you can get 3. If we run that, you could see in this case we got 3. And it's a good convergence because this is 1. So maybe we want 5, and so really you're going to want to change your initial condition. So let's say we change it to 4.5. We run that. Okay, we got 5. So really, if you look at the equation itself, so this is a plot of the equation. These two red points here are the 2 points where it solves. If you start on this side of the equation, it's going to solve towards this point. And if you start on this side, it's going to solve toward this point. And that's because it's gathering up. If it starts up here, it's going to pick up that it's the slope is down this way, and so it'll follow it down that way. If you do it here, it'll go up. Subsequently, same here, it'll go up this way, and then here, the slope is going to look down that way. Now I'd like to demonstrate it using two variables. So one of the things that this solver can do is solve for more than one variable going in. So now we have a u1 and a u2. We'll call it that. Another nice feature is that you can just mux the inputs together and it'll figure out what it needs to do. You do, however, need to change your Jacobian perturbation size, which we'll just keep it the same, but, you know, add another one. So 1, 1. Okay, so by inspection we can look at this and you can say that u2 minus 5, the answer to that one is that u2 is equal to 5. If you then take that 5 up here and you do 5 minus 3, you get negative 2. And the only way negative 2 can be equal to 0 is if you multiply it by 0. So that means this guy here also needs to be 0, and u1 needs to be 5, because 5 minus 5 is 0. So let's see if the solver can figure that out. Okay, it converged, and you have 5 and 5. There's a couple different things to look at here. You'll notice that now our Jacobian matrix is a 2 by 2, and that's because we have two input variables. Really, this first variable here is u1, and the second one is u2. If you look, this one is u1, and this one is u2. So as you look down this way, this would be the slope there, and then this would be the slope here, and you can see that this is 0, so that means that that particular item, u1, does not appear in function 2. Here you can see that you do get a slope here and you get a 1 here. This 1, because this is a linear function, aligns with the slope of this u2. So let's look at how it actually solved. It was a little bit more complicated. It looks like the second one solved fairly quickly, runs up to 5, and then this other one kind of comes down and then goes, oh, well, I guess I'm really supposed to be at 5, and it goes back up. You can look at the error as well. So here you can see that initially it was on the right track. However, once this second guy was determined and its value got to 0, it found that it wasn't doing the right thing, so it had to turn it around and change its tact, and it comes back and finally does solve for it. And that's with it changes the Jacobian. There's 20 iterations here because we had it set to 20, and so then after 20 it says, oh well, we have to recalculate because this isn't working. So it does that. And then finds the correct answer. Okay, this is good for functions that we can solve for by inspection, but what happens if you can't solve for it by inspection? Can it do something more complicated? And I have a few functions here that I kind of prepared beforehand. And so we'll get rid of these, and we'll put these in here. So this first equation is a linear function with three outputs, or sorry, inputs. We'll have to set this guy to 3. So the first one is 2 times u1 minus 5 times u2 plus u3 plus 5. The second one is negative u1 to the third plus 2u2. The third one is u1 times u2 squared minus 2u3 minus 3. So we'll just kind of stick this guy in here, and we'll expand this to be one more. And we'll run this. Okay. So first off, you can see here that it managed to converge. So it found the answers, and this is them here. They're not as clean as the ones we had seen before. You can verify that it found them by looking at these. These are also not as low as we'd seen in some of the other examples, but they do meet the criteria, and really that's all we're looking for, because it won't try to meet anything greater than the criteria. There's a couple things to note when looking at the Jacobian matrix. First off, it's a 3 by 3. Second, with this linear function here, you can pretty much just read it off right here. There's 2, -5, and 1. So 2, -5, 1. With the second equation, you can see that there's a 2 multiplied by that first one, so you see to 2 here. And also there's no u3, so you can see that there's a 0 here, signifying that it doesn't exist. Similarly, there's a -2 here, and you can see that -2 here. You can calculate these. It's based on when it calculated the last Jacobian, so it makes it a little more complicated, but you can look at that and you can be certain that these variables do appear in those equations, which is, it's a nice thing to be able to know, because sometimes you don't have access to these equations. These solvers many times are used in things that are very complicated, and you don't know exactly what your plant is. So you can find some things out about it by looking at your Jacobian. So if we look at how it solved, you can see that it did fairly well. It started at 1, and each one of them kind of took off towards thing. This kind of went in the wrong direction a little bit, but kind of came back. They tend to jump around a little bit. That's fairly typical with this type of solver. Similarly, you see that each one of these started at a different point and then comes down and gets to 0 around here. They also jump up and down, but that's okay. This concludes the TMATS solver tutorial.